any two terms, take the next term and subtract from the term you're looking at right now. So 25 minus 19 or 31 minus 25. You can see it's going up by 6. So if the common difference is positive 6. And then we always want to find our nth term formula. So u sub 1 plus n minus 1 times d. And then plug in something that you know. So I know the first term is 19. That's u sub 1. And I know the common difference is 6. So I have a general formula, and you could simplify that if you want. You can leave it like that. So if I want to find, let's say, like the 20th term now, instead of listing them all out, or if I want to find the 100th term, I can now just plug in 100 for n. So 19 plus 99 times 6. So 99 times 6, 594 plus 19, 613. So the 100th term is 613. And so you can, once you have the nth term formula, this is the nth term formula, once you have that, you can find any term, which is what we want to do. We don't want to have to, it's fun to list them for a little bit, but then it gets tiring, especially if they've said to the 1000th term. Okay, so let's do another one here. So I have another arithmetic sequence, and it's going down by 4, so the common difference is -4, or adding -4, if you want to think about it that way. And if it says verify it, you just show a couple things subtracted. So 97 minus 101, 93 minus 97, it's all the same there. So I want to immediately find the nth term formula. So the first term plus n minus 1 times the common difference. And be careful that you just remember that's multiplied there. So again, let's say I want to find the 72nd term. All I got to do is plug in and simplify. So 4 times 71, that would be -284 plus 101, -183. And that would be a giant pain to list all those out. So the other question that might happen here is they might say verify that I don't know, 82 is, let's go 81. Verify that 81 is a term in your list. So if it says verify, now you can go back to your nth term formula, which is where we always start, and say, okay, they're saying 81 is in the list. This is like a show that question. Show that 81 is in the list. You could actually find out what term it is. So you put 81 in for n, or use of n. We don't know what n is, but we do have everything but n. So if we can solve for n and not get a decimal, this is distributed property kind of on the different direction. If we can solve here and get a number that is divisible by -4, that's -24 equals -4n, n would be 6. So that means 81 is the 6th term. That's how you can verify that. So it always goes back to any question you're doing, do you have the nth term formula? And if so, write it, see what you can plug in, because there's variables in there that you can find. Okay, so the next one is geometric sequences. And geometric sequences have a common ratio, and people are usually pretty good about ones like this, but when it's in this form, sometimes people get confused. So this is, if you look at it, we can tell it's being multiplied by 2. That means the common ratio is 2. To verify that, you could take the previous term divided. So 6 divided by 3, 12 divided by 6, those are all equal to 2. Okay, so we immediately want to find the nth term formula, u sub n. u sub 1 times r to the n minus 1. Plug in what you know. I know the first term, and then I put the ratio in parentheses just so I don't make an error in my calculator. So now we can plug in any term and figure it out. So let's say we want to find the 10th term. So it would be 3 times 2 to the 9th, which geometric get really big or really small fast. So that's 1,536. Again, you could list them out. That'd be a big pain if you had to do that. Okay, so again, if you find the nth term, now you can figure out anything. If we go just up to 20 there, 3 times 2 to the 19th, it starts to get crazy big. Your calculator sometimes will give you big time decimal or big time numbers using scientific notation, so just be careful. So it jumps really fast. Okay, the second one, and this is one that's more likely to screw people up because they recognize what's happening there. They don't know how to say it in the right notation. So what's happening is that our denominator is getting smaller by 2. So it looks like you're dividing the denominator by 2. Sometimes when you divide by 2, that's like multiplying by a half. This happens to be a fraction. So this happens to be multiplying, but you might not notice that. So when you have any kind of any fractions or things are getting small, I always just tell people find the ratio using our rule. So negative 1/8 divided by 1/16. So division is the same as multiplication by the reciprocal, or if you don't understand that, you can use your calculator. So my r is negative 2. So we're actually multiplying here by negative 2. That's the common ratio. If you don't believe it, you can do it again. You're skeptical. Negative 1/2 divided by 1/4. If you multiply by the reciprocal, you get negative 2. So r is negative 2. If you have values that are getting smaller and actually getting smaller, this one's actually getting bigger, you might have r be a half. So the difference between a half and 2 is a big deal. So with r, I would just suggest you use the common ratio formula. So we get our u sub n times r to the n minus 1. First term is 1/16, and then negative 2 to the n minus 1. So if I wanted to find the 20th term, I'm just going to plug that in and use parentheses on your calculator, or use a fraction button if you have it. You spent the big bucks for the fancy shiny calculator. That this is going to be numbers get really big or really small pretty fast. So 32,678. You would not want to have to list those out. And a couple things you can do to help yourself check as you know it goes odd and even and odd and even. I actually typed that in wrong. That would be negative 32. That was my check right there, because all of the odd terms up here are even. So any of the even terms should be negative. So that's a negative. I put a negative 1/16 in there. Again, these numbers get really big really fast. The next round we'll learn how to add all these numbers up, and there's some pretty cool stuff about sequences that way. But that's for another time.